And first, let's start with the electricity section. Then we will go in the reverse order. Winter 24, paper 4, variant 1, specific heat capacity, electricity, electromagnetic induction. Okay, so we are starting from question number 7 first. Uh, so we can solve like 7 questions from this paper because other 2 questions or 3 questions are from nuclear and space. Okay. So basically, question number 7 is related to magnet and electromagnetism. A solid bar is inside a copper solenoid. It shows that copper solenoid is connected in series with a battery and a variable resistor. So in the diagram, all components are connected and given. The device shown in figure 7.1 is an electromagnet because when we turn on the current in this coil, so magnetic field generates around the coil and the bar in the center of the solenoid also gets magnetized. That's why it is called electromagnet. So first of all, suggest a suitable material for the bar. So which material we have to use for electromagnet? We have two types of material that we commonly use in our example, iron or steel. So if we talk about the material, so we are going to use iron because steel is a permanent type material. So if we use steel and when we turn on the current in the circuit, so that steel will get permanently magnetized and then it will be difficult to unmagnetize it. So that's why we always use iron or soft iron for electromagnetic material because it can easily magnetize and demagnetize. So we use soft iron. Okay, next part is the right hand of the bar is the south pole. Figure 7.2 shows the bar viewed from the above. On figure 7.2, draw at least 6 field lines to show the pattern and direction of the magnetic field surrounding the bar. So let's see figure 7.2. So this is 7.2. Right side is the south pole. So definitely left side will be the north pole. And we have to draw at least 6 field lines to show the pattern and direction of magnetic field surrounding the bar. So this is very easy question and this is from 2024 paper. So we know that magnetic field lines travel from north to south pole. So let's suppose one magnetic field line is moving outward. From south it is inward. Other one is also moving outward. Inward, inward. So we also need to show the increasing gap between the field lines. So this is the pattern of the magnetic field lines around the magnet. Second part of the question, the resistance of the variable resistor increases. Explain what happens to the magnetic field surrounding the bar and state how the pattern of field lines that represents the field changes. So variable resistor is connected in the circuit and that is in series combination. So if we increase the resistance, so definitely the value of current also decreases because the value of resistance increases, so the value of current decreases. So first of all, current in the coil decreases, and when current in the coil decreases, so because of the current in the coil, magnetic field generates around the coil. Because when current passes through the coil, so magnetic field generates around the coil. So when the value of when the value of electric current decreases, so definitely the magnetic field also decreases around the coil. So strength of magnetic field, strength of magnetic field around the coil also decreases. So basically, when the magnetic field decreases, it means the magnetic field lines are less in the quantity because of weak magnetic field and also they are away from each other. So the pattern of field line shows less number of magnetic field lines less number of magnetic field lines and gap between lines also decreases. Now in C part of the question, a square coil of many turns is placed closer to the bar. It shows the plane of the square coil parallel to the flat circular surface at at right hand end of the bar. So now in this diagram, we have a bar and a copper solenoid, the same setup shown in the first figure, but there is now one square coil on the right hand side of this bar. And the question is the resistance of the variable resistor is alternatively increased and decreased. So explain what happens in the wires of the square coil. So this is the square coil around this bar. So definitely when current passes through the coil, it generates magnetic field and it also magnetizes the copper solenoid bar inside the copper solenoid. And that magnetic field also affects this square coil, which is placed on the right side of this copper solenoid. So we can the value of the resistance alternatively increased and decreased. It means the value of current also alternatively increased and decreased. So there is change in the value of current. So we can simply say that because of change in resistance, alternately, the value of current also increase and decrease alternately. And definitely when the value of current changes, it also changes the magnetic field, produces changing magnetic field around solenoid and it cuts the square coil also. And definitely you remember because of change in the magnetic flux linkage, this is the concept of change in magnetic flux linkage. And because of change in magnetic flux linkage in the square coil, which is newly included in this diagram, in the first diagram, that square coil is not present. So we also get induced EMF in this square coil and EMF induced in the coil. So this is the first question from electromagnetic concept for 10 marks. And if we consider the other question, question number 6. Question number 6 is from electricity part. A potential divider is made by connecting LED, LDR and a thermistor in series. So again, we have two components given in series. Figure 6.1 shows potential divider, a voltmeter, a direct current power supply connected into circuit. So we have DC and voltmeter also. The voltmeter measures the potential difference across the LDR. So define potential difference. So according to the definition of potential difference, it is energy converted or energy conversion per unit charge between the 2 points in the circuit. So energy converted per unit charge so energy converted per unit charge Okay, so it is energy converted per unit charge across two points in the circuit. Now in B part of the question, the EMF of the supply is capital E, and describe how the potential difference across the thermistor can be determined using the reading on the voltmeter. So in B part of the question, EMF is given, and we have to describe how potential difference across thermistor can be determined using reading on the voltmeter. So according to the diagram, this is the diagram given. Current is moving from left hand side to right hand side, and first it is passing through the LDR, then it is passing through the thermistor, and the question is to find out the potential difference across the thermistor. It means this one. So definitely voltmeter is connected with LDR, and in series combination voltage divides. So definitely we have to add the voltage of both components, and then we will get the total value of EMF in the circuit. So it is very simple. We can say that by subtracting potential difference across LDR from EMF, because it is in series combination, and in series combination voltage is splits among the component. So EMF is the total value, and if we subtract the voltage of LDR from the EMF, so you will get the voltage of this thermistor. LDR equals to voltage of thermistor. Simple. Then in C part of the question, the resistance of the LDR decreases and resistance of thermistor increases. State what happened to the light intensity incident on the LDR and the temperature of the thermistor. So now the resistance of LDR decreases. Resistance decreases for LDR and resistance increases for thermistor. State what happened to the light intensity. So when resistance decreases, so light intensity increases because both are inversely proportional. And when the resistance of thermistor increases, so definitely the temperature of thermistor decreases because it is also inversely proportional. So in the first option, we have to write increased. And in second option, decreased. Because both are inversely proportional. Then in the second part, explain what happens to the reading on the voltmeter. Okay, so basically we know that battery or EMF of the battery is same. EMF of the battery is same. It means total voltage remains the same. But now, as we discussed that for LDR, resistance decreases. So resistance of LDR decreases. So voltage also decreases. But the voltage of thermistor increases because resistance of thermistor decreases. So in simple words, the voltage of LDR decreases. It means the reading of voltmeter also decreases because voltmeter is connected with LDR. So it reads the value from LDR. So answer is simple. First of all, we say EMF of the battery is same and the voltage or potential difference across LDR decreases because of decrease in resistance. So the voltage or the potential difference across thermistor increases. It means now thermistor is taking a greater part of the voltage or greater share of the voltage, and the other component is taking, like LDR is taking a small part of the voltage. So this is the process. Now potential difference across thermistor increases. So reading across voltmeter also decreases because of LDR. So it is also simple and it is related to the series combination. Now the third question. Okay, question number 5 is now from the wave section. A loudspeaker produces a sound wave in air. The distance between the center of compression and the center of neighboring rarefaction. So it is the distance of center of compression with the center of rarefaction, which is 0.1. So calculate the wavelength of the sound wave. So first of all, if we consider the wave fronts, because without wave fronts, it is difficult to identify what is actually given in the question. So first of all, if we have compressions given, then we have rarefaction, then again compression, rarefaction, compression. So they are talking about the center of compression and rarefaction. So this distance is given. And we also know the distance between two consecutive compressions or rarefaction is equals to the wavelength. So this distance is actually half wavelength. So if we double this distance, so we will get the total value of the wavelength. So the value given is 0.1, and to find out the total value, we have to multiply this value by 2. So 0.2 meters is the answer of the wavelength. And B part is state a typical value for the speed of sound in air. So we already know we have to write a fixed value for the speed of sound in air, that is equals to like you can write any value between 330 to 350 meter per second. Meter per second. Now calculate the frequency of the sound from the loudspeaker. So we have to calculate the frequency. So there is only one formula we discussed, V is equals to F lambda. Speed is constant. So we use this speed 330 because it depends upon the value that we used in the previous part divided by the wavelength given 0.2. 330 divided by 0.2, 1650, or you can also round it off to 1600. In the second part, explain whether the sound from the loudspeaker is audible to a human with normal hearing. So now we are getting frequency 1600 hertz. It means the audible range for the human being is 20 to 20,000. So this range is audible. Yes, it is audible. It lie in the range of 20 to 20,000 hertz. Okay. D part, another loudspeaker produces a sound of wavelength 0.4 meter. Sound from loudspeaker reaches a sound absorbing surface with a gap of width 0.8 meter at the center. So this is the gap of 0.8 meters. Explain whether it is possible to detect sound from the loudspeaker at either point J or at point K. So they are talking about 2 points, either J or K. So at which point, or what do you think at in the according to the given diagram where it is possible to detect this sound? So basically, when sound waves travel from the loudspeaker, so because of the gap, diffraction occurs. This gap is 0.8 and sound wavelength is zero point 0.4. So it means that in this question, gap is greater than wavelength because wavelength is 0.4, gap is 0.8. So wavelengths are small. So it means that this time we have less diffraction because of large gap and small wavelength. So we have less diffraction, and because of less diffraction, we will get a slightly curved wavefronts. So that will not reach point J because point J is very far away from the center gap. And if we have more diffraction, so it diffracts in more directions, in multiple direction with different angles. But this time we have less diffraction, so it will not spread out in uh, with greater angle or in multiple direction. So that's why it is not possible to detect sound at J, but it is possible to detect sound at K because K is in front of the waves. So when wave travels in forward direction, so definitely at this point we are able to detect the sound. So explanation is, if we talk about J, so no sound detects because of small diffraction. The reason is wavelength is smaller than the gap. But if we talk about point K, so point K, sound detects at this point because waves after passing through barrier easily reach point K. So this is the explanation of this specific part of the question, which is depending upon the diffraction. And now moving towards question number 4. Question number 4 is related to thermal. Question number 4 is describe an experiment to determine the specific heat capacity of aluminium. You may draw a diagram. Include in your answer measurements made and equations needed. So this method is already we discussed in the notes. In notes we discussed we have to set up. We use electrical heater because we are using electrical heater. Electrical heater helps to measure the voltage and electric current, and with the help of that electrical heater we can easily record the value of voltage and current to find out the value of electrical energy. Because if we are using a Bunsen burner or any type of burner, so it will be difficult to record the value of energy from there. So that's why we use electrical source of thermal energy, because when we heat up with the help of electrical heater, so that will help us to calculate the value of electrical energy. So we are using electrical heater, and with the help of electrical heater we can easily record voltage from voltmeter. Process is simple, we have to start heating up the liquid or aluminium, and after equal time interval we have to record the value of temperature from thermometer. And after repeating this experiment for multiple time, and we will get a sets of reading like 10 reading, 15 reading. So that is the reading for the time, and we can easily measure the voltage from voltmeter, current from ammeter. And the equation we are going to use is equation of energy, VIT. So we can substitute the value of voltage over here, the voltage we kept during this experiment in the circuit, and we can also take the value of current that we used in the circuit, and finally the value of time that we record from the experiment. So this help us to find out the value of energy, and finally we can find out specific heat capacity by using this formula. And we can measure this mass with the help of electronic balance, and we can measure temperature with the help of thermometer. So this is the simple idea we have to use in this question, and this is like a copy paste method. There is nothing new in this method. The only thing we need to remember the electrical energy source, because if we use a normal fire or burner, so it will be a problem to observe or calculate the value of energy from that Bunsen burner or any type of burner we are using. Now in B part, an aluminium dish is initially at room temperature. Boiling water is poured into aluminium as shown in figure 4.1. Explain why after a short time the dish and water are at same temperature. So definitely initially we have low temperature for aluminium dish and high temperature of boiling water, and when they make contact with each other, so definitely the hot body starts to transfer energy towards the cold body. So we say that heat from hot water starts to transfer high temperature to low temperature of aluminium, and energy transfers through conduction, because they are in direct contact, so definitely energy transfers through conduction. when they reach same temperature, transfer of thermal energy stops. So initially, thermal energy transfers from hot body to the cold body, and at a certain time, when the temperature of both bodies becomes equal, so then the transfer of thermal energy from high temperature body to low temperature body stops, and no thermal energy then transfers from hot body to the cold body. Now, in second part, explain in terms of particles why aluminium expands as the boiling water is poured into the dish. So now this question is related to expansion. So definitely when boiling water poured into the dish, so kinetic energy of the particles increases and starts to move away from each other, and this will cause expansion in aluminium. The last part of this question is the water in dish evaporates. Explain in terms of water molecules what is meant by evaporation. So concept of evaporation is very simple. Escape of high energetic particles from the surface, leaving low energetic particles on the surface. Right? So these are some questions from October, November 24, paper 4, variant 1. And we will continue with the practice of more question in our next class, right? You can also try questions from 2024 and 25 papers, because 2023 and backward, all those questions are included in the topical files and we practice them with every topic of electricity and electromagnetism. Now for new question, you can practice from 2024 and 25 papers, right?